This is going to directly lead into what we're about to get into. What I want you to do is, can you please draw me a rectangle that has a perimeter of 13. So let me do an example. I'm going to draw my rectangle like this. I'm going to make this 2 and 2. How much do I have left? 9. So make this 4.5 and 4.5. Do you guys understand?
Yeah.
So there's my rectangle. Don't use my rectangle. That's mine. Nay. Can you guys make a different one? We'll make this feet so we make this physical. Bless you. So think of this as I've got this much fencing and I want to fence in a rectangular area.
Oh, we're doing this one.
Yes?
Yeah.
I don't try to read too much into this. This could be anything. But yes, we are doing it. And this is a question I can ask intermediate algebra students. Yes. This would lead into word problems with that. So everybody should have some kind of a decimal side. Yes. Does everyone have a rectangle set up? Yes. Oh, wait. You did what'd you do? 1.5 here? 1.5? Okay. 5 and 5. I love it. Kick ass. Now, real quick, before you start shouting at me your rectangles. That kicks so much ass. Did you have to make one long and skinny like this?
No.
You could have tried to make one more, compact or whatever. I don't care. Whatever your rectangle is, has everybody got one? Don't tell me what it is. Figure out what its area is. So my area is 9 square feet. And of course, it's length times width. Did anyone get a bigger area than 9 square feet? What was your rectangle?
Mine was 2.25 by 2.25.
Do it again, sorry?
2.25.
2.25? 3.25 and 3.25. Oh, you. So what's your area?
10.565.
Did anyone else get a bigger area than 9 square feet? Anybody? Can somebody give me, what was your area back there? Did you multiply these? What'd you get? 7.5. Okay. Would you all agree, even though I didn't draw it that way, just because I drew it before I knew what the numbers were, that Dima's rectangle is skinnier than mine and longer than mine? Yes? So it looks like the skinnier and longer I make it, what happens to the area? It shrinks. Do you, and of course, what you did back there was you made a square out of it. You just took 13 divided by 4, and that makes sense. I was kind of hoping nobody would do a square, but it's okay. There's a sweet spot. Every single one of these, every single one of these uses the same amount of fencing, yes? But one of them uses the area the most effectively. It gives me the biggest inside to work with. And that would be the one that's actually a square. Yes? So real quick, the point of this is, if I have certain restrictions, so what was the restriction here? I had only so much fencing. There could be a sweet spot where some other thing, like the restriction here was about perimeter, and that leads to there being an optimal setup for a maximum area. Are you guys not all with me? So this is a concrete example of what we're about to get into. The funny thing is, anytime I have a 4-sided figure, a square is always going to make it the best. What gets more interesting is if one of my sides is missing or something, then it's not going to be a square anymore. Okay. So what we're getting into is officially called optimization problems. Now, you've done these problems in pre-calculus, believe it or not. Do you remember what the vertex signified? If I have a down parabola, what's the vertex? What else can I call it? Especially because we're in calculus. It's not inflection point. Maximum, yes. So I don't know if you remember in pre-calculus you had problems like
Profit function is this. What's the maximum profit? How many widgets do you have to sell?
how many of these toasters do I have to sell to make the most profit? And that just meant find the vertex. And do you guys remember the shortcut, negative b over 2a?
Yeah.
Some of you guys are listening. Real quick, I don't think I've done this yet, but here is every parabola that ever existed, yes? How would you find its turning point in calculus? So remember, the shortcut from pre-calculus was this. And if you had me, I told you where that came from. It came from a quadratic formula, believe it or not. But we're going to get it a different way. How would I find this guy's maximum? We're in calculus now. We know how to do this shit. How do I find any function's maximum? What's the first step? Derivative. What's the derivative? Don't overthink it.
2ax plus b.
And then, can this be undefined? No. So where do I get my critical numbers from? I make this 0. And what do I get when I solve for x? I get something that looks very familiar. Yes? So that is the calculus derivation of the shortcut to find the vertex of a parabola. Because what is calculus able to do that algebra is not able to do as well? Find x's and mids. For parabolas, their maximum min is simple. The minute I make a cubic, algebra has no freaking idea. It's like, So when you draw a cubic, it does look parabolic in places, yes? But it isn't. The curvature is different. So algebra has no idea what to do with that shit. Of course, now we know how to do that shit. So what's going to happen is this. Let me do a very basic example. And then I'm going to show you why this is word problem territory. If I did give you a profit function, let's see if I can make one that sort of makes, who knows, Jeff? I'm going to make something up and hopefully it's going to make some sense. That might be too much, I don't know. Oh shit. Let's just do this. Okay, let's see what I've done. Oh shoot, I want to make it more interesting. Damn it. Ah, fudge. Hold on. Scratch that. All right, we're all gonna see what Jeff has done here in a minute. Let's see what Jeff has done. Could algebra handle this to find the potential maximum or minimum? No. What do we do?
Derivative.
Derivative.
Negative 0.03x squared plus 40.
Good. Can we solve this? Yeah, totally. So if I divide by negative, so if I set this equal to 0, subtract 40, divide by this, end up here, and then I take a square root. Is that cool? Now, it'd normally be plus or minus, but here I'm assuming x is like the number of toasters. Yes? So then that you would just plug in the old calculator. What would it be roughly? 1300. Let's say 34.
36.50.
I'll retire. Sorry. That's way off. What's wrong? So like 36?
Yeah.
Okay, now. This problem was much easier than most of the problems in this section, in section 4.7, because they gave me the formula. Now, we should be ready for this. We're going to have to create the formula most of the time. Yes? Okay. But just to show you, if I do have the formula and I want to find a max or a min, I get the critical numbers. Now, to make sure this is a maximum, I should either do a second derivative. If I do a second derivative, what do I get?
0.06.
Negative 0.06. That's important.
0.06x.
Yes?
Yeah.
And what is the value? What at this, is this positive or negative? Negative. So that would mean that is a maximum. Okay, so then I verify. Because if I'm in the real world and my boss is like, hey, how do I make the most profit? That's your job. Tell me. And you sell, and this is actually a minimum. That's my blue problem. Like, oh, sorry. Then, no, you're out. You're gone. You guys come on. Okay. So what I just did is a problem that could have showed up early in chapter 3. Find the critical numbers, second derivative test, early chapter 3 stuff, yes. The change now is going to be, we have to create our own formula for most of these, just like with related rates. Now, I did tell you, does anyone remember what I said about the level of difficulty with these problems versus related rates? These problems are normally easier. So you can tell me later if you agree or not. One nice thing, well, let's do a problem. Let me see if I can make a problem up. This should be exciting. Yeah, I'm gonna make a very low level problem up. Say I have two numbers. Two positive numbers. They add to, 10. Oh, this one's silly. What's the maximum product? Okay, so this one you could actually figure out pretty easily on your own, but let's try to set the work up. Let's try to set the calculus stuff up. How many relationships do you see in there between the numbers? So we have two numbers. How many things am I actually mathematically doing with them in the problem?
Big one, adding.
Adding is one relationship that I need to investigate. And what's the main thing I need to investigate? Multiplying them. So do you guys see how there's two relationships between the variables? One of them is what I call what they tell me. They are always going to tell us something. Just tell me straight up. And they're always going to ask us something. What I'm trying to do right now is the same thing I do when I teach just normal word problems. If you break the problem into parts, it's much easier to focus on each part. What part of this problem is just something to just straight up tell me? They just tell me this is true. What do they just tell me?
They're telling you that they add to 10.
Yes, good. Now what am I missing to capture that mathematically? I want to write an expression.
X plus y.
Write an equation. Yeah. So I got to give my numbers names. I don't know what either one is, so we're going to call it x and y. So they tell me that x plus y is 10. That's amazing. So write a formula for what they tell you. It's technically called the constraint function. That's dumb. It's what they tell me. It's not dumb. It's the name of it. It's just the technical name of it. But it's not really useful to call it that. And the other one's technically called the objective function. Don't give a shit. It makes more sense to say what do they ask me? So what do they ask me to investigate?
The product.
The product. How do I write the product of those two numbers?
X times y.
And I'm going to give it a name, a function name. I'm going to call it P because I'm crazy. P for product. You can call it M for multiply, or W for what the shit. It's up to you. Almost every optimization problem is going to work like this. They're obviously not going to be this straightforward all the time, or this easy, but they're going to have a relationship they tell you, write the formula for that. You have to pick the variables. And in a relationship for what they ask me, you write that down. Okay. How do I find the maximum of anything? Now that we're in calculus, how do I find the maximum of any function?
Derivative.
Take a derivative. What's wrong with this function though?
It's all very. It's just.
Too many damn variables. Yes? The number of variables in this equation is too damn high. Right? Is that being too old now? Shit. Can I use this information to help me rewrite this?
Yeah.
To have one less stupid variable? What do?
You
Subtract y.
Sure, you can solve for either thing. I don't give a shit. Whatever's easier, and they're both easy. So if I subtract y, I now know what x is. So when I write the product, what would it be? It'd be
10 minus y.
good. 10 minus y
Y.
times y. So what do I get?
10y minus y squared.
How do I find the maximum
Find the derivative.
derivative? What's the derivative?
10 minus 2y.
I want you to realize, what did we just take the derivative with respect to y? This optimization problems are not about letting time go by and see how things are changing. This is literally, if I make y different, then x is different. Do you guys agree with me?
Yeah.
If I change y, then I change x. And that's why when I take a derivative, it's y that's changing. I take a derivative with respect to y, not so that's another thing that's better than related rates, is that I'm not going to have this weird chain rule dy dx or dy dt, dx dt, that kind of stuff. What do I do now? You took a derivative, trying to find the maximum,
Find the zeros.
find the critical numbers. Holy shit, maybe right, well. And of course, what's y?
Take out 2.
Add 2y, divide by 2. Yes?
Yeah.
Okay. Now, some of you guys might realize, I don't know if anybody realized this is effectively a rectangle question. If the sides add up to a number, what's the max product? It would be a square. If y is 5, what's x? 5. So this is another application of, and what I actually asked for,
Max product.
max product. So what's the actual answer?
25.
That's insane. Okay, so always at the end of the word problem, make sure you answered the actual question. Yes. Don't just get a value and stop and go, hey, look at me. So, what I want to do is I've made a, you're not going to believe this, I made a worksheet that focuses on one part of the setup to this. So let's look at the side that says function writing practice. So number one should be really straightforward. Can you go ahead and try to do number one? A really decent idea with these kind of problems is to draw a picture. Number one should be, we just did a problem. Break it down. Do they tell you something? Do they ask you something? Yes. Focus on each of those separately, so you don't have too much in your head.
So you're taking the derivative of the derivative. Right?
Is there any calculus anywhere in this problem? Am I asking you to find max or min or anything?
No.
Okay. Now listen, I understand. We're in calculus class. I understand. But like I said, this is just focusing on the beginning of these kind of problems. So yeah, what do they tell me?
You have 40 feet of density.
So what variables do you guys want to use? I'm going to use different ones just to be different. I'm going to call this L for length and width W. If you use y and x, I don't care. Yes? Whatever you called the width is what I want to end up having a function of. Okay. So they tell me that, how do I write this exactly? What's wrong with this?
Because you need two of each.
Yeah, L plus W is only halfway. Now what's funny is L plus W is 20 is true. But most people know 2L plus 2W is P. You should never memorize any perimeter formulas, but that one's already in your head. So that's what they tell me. What do they ask us? Yeah, they ask me about the area. And from my picture, what's the area? Yeah, so whatever variables you used. Now, can somebody tell me if you drew a rectangle, or if you drew a square, so you draw a rectangle, which letter did you use for your width? Did anyone use Y here? Anybody do X and Y? Yes? Okay. What did anybody else do? What letters did you guys use?
Length and
You used L and W? Aw. Aw. Anybody else do anything else? Do you only call us Doug and Jeff? I don't give a shit. He can call it whatever the hell he wants. Okay. I chose W. This is the part that's really tricky. Not really tricky, but so what does it want me to do? It wants the area to be a function of width. So which letter do I not want to be here?
L.
I don't want L to be here. Which means I want to solve this equation for L. Good. For some reason, students get that turned around. If I solve this equation for L, Jeff, you just said it. Then I can replace L with that, and then I will only have W as the variable. And then I could do like calculus of that shit. I didn't ask for that. So you don't have to do calculus on this worksheet yet. So then area will be, where'd I go? Here. 20 minus W times W. Area will be 20W minus W squared. That's all I want. Yes? Try to do number 2. Can you guys draw a rectangular container where you just do this kind of thing? Yes? It's a really good idea to give yourself a physical thing to work with. And I'm very nice here. I tell you exactly what the variables are. I don't do that all the time. Do you know what the volume of a rectangular solid is? Length times width times height. So what do they tell me? Write a formula for that. What do they ask me? Actually, it was nice. Gave you the formula for that. Actually, I think it's the other way around. What do they tell me here? Yeah, I did turn this around. What physical idea do they tell me?
It's a rectangular container with the square facing like the weight and height. Top.
Great, that's nothing specific. They just tell me something specific.
It uses
The-
1,000.
Yes, that uses 1,000 square feet of material. Now, what geometrical idea is that related to? Is that volume? Area?
No.
It's
That's
area,
area.
surface area. How do I construct it? I need this side, and I need this. The material goes into making each side. That's going to be the surface area. So they tell me the surface area is 1,000. So that's what they tell me. And then they ask me about the volume. So go as far as you can. See if you can't do the next step. I already told you what the volume formula was. You know which letter you want to get rid of. Go for it.
Huh? Yeah, like that.
formula should come out looking a little gross. What do they ask me about geometrically?
Length,
Huh?
volume,
Volume. And the formula for that in general would be
length times width times
good. And for us, in this specific problem, the length is
height.
x, the width is
X squared.
x, and the height is h. That is the volume of any rectangular solid, any, with a square base. Yes? This one I want specifically has to follow this constraint. What letter do I not want to be here anymore? I don't want h because I told you I want to write the volume as a function of x. How do I get rid of the letter h? Do I have other information that can help me?
You
Divide by two.
And towards what purpose? What are you doing that for?
Take the x squared by two.
No. What letter do I want to get rid of here? So if I only knew what h was, I could replace h with that. So what do I want to do here?
you want to isolate h.
Isolate h. I don't want h here. If only I knew h equaled 7x or something, then I could replace it and get rid of the dumb thing. I want to replace the h. That's what variable you solve for here. Whatever you want to get rid of, you solve for it. So most of these problems work like this. They tell me information, I write the equation for it. They ask me about something else, I write the equation for that. Then I go, how can what they told me help with what they asked me? So in this case, I can solve what they told me for h. How do I solve for h?
Divided by 2.
I like divide by 2, I like that.
Now you can take out x.
Don't take out anything. How do I solve for h? What term has my h in it? How do I get that by itself?
Divide by
No. How do I get this by itself?
Move the x squared.
There we go. And then now how do I get the h by itself?
Divide by two.
Divide by 2x. So now I know h is 500 minus x squared over 2x. And what did we do that for? I don't know, Jeff, you just like playing with numbers and letters. What did I do that for?
So you kind of isolate. So you could replace.
So now I
the
know what h is. And that's from what they told us. I can take this and I can plug it in here. So now the volume is x squared times 500 minus x squared over 2x. Can you simplify that a little bit?
500 over 2x.
Huh?
Oh no.
How many x's cancel?
1.
1. Then I could distribute the x. Yes? And then I could even divide both by 2 if I wanted to. Are you guys with me? Maybe? No? Now, on this worksheet, that's where we stop. What would I do next if this was a calculus problem? Take the derivative, because the question would be, what's the maximum volume I can make, given this constraint? So then we would take the volume formula we just created, take the derivative, get the critical numbers. Yes, maybe, no? Number 3 is a little bit weird, but I don't know. I guess I just wanted to throw it in there. See what you think about number 3. There is something they tell us, but it's not a number. And there is something they ask us. This is a little more like a related rates problem.
You replace the B with 3H.
Sorry?
You replace the B with 3H.
Well, what's this? How do I, what did they tell me?
The height is 3 times.
Height is 3 times diameter. Now, does that relate to the variables I'm going to be using?
Yeah.
It does, but not directly. How do I make it relate directly to the variables?
Replace B with pi r squared.
No, you're overthinking it. How's the diameter relate to the radius? Yeah, the diameter is just twice the radius, yes? So now I know my height is 6 times the radius. And what do they ask me about?
They're asking you about
Running a volume.
Volume. So this feels a lot like that one quiz we took. So how do I write the volume as a function of height? What's one thing I need? So what letter do I want to get rid of then? R. So what's wrong with the way I've written my tell me equation?
That's H.
Yeah, that would be good if I want to get rid of H. So what do? I just... Yes, so now I know R is H over 6. I can put this in place of that. So let's see, H squared times H is H cubed. 6 squared is 36. So that's quite a bit like the one quiz we took, quiz 4, I think it was. You guys at all with me? So I could look at that kind of problem as a tell me, ask me problem. All right, now try number 4. Go for it. I will let you guys work on this more yourself. Try number 4 out. Oh, shoot. Did I put it up here? Yeah, the volume for a cylinder is up here, right? For the last problem? Yes. Don't forget, there's the volume for a cylinder, yes? So you want it as a function of the radius. So which letter do you want to get rid of? Well, wait a minute, sorry. They tell me the volume. So why did you put the surface area formula here? I need the volume area, right? Volume area, volume formula. They tell me the volume is 60. You just took the surface area and equaled it to 60. What's supposed to equal 60? Volume. And that's what they tell us.
The volume. So I put the volume formula for the cylinder.
Yeah, so they tell me the volume is 60, and the volume of a cylinder is a circle pi r squared times how long it's repeated, h. So pi r squared h equals 60. They ask me surface area as a function of only the radius. So the way the surface area works is like this. Is it currently just a function of the radius? No. What's it also a function of?
R.
That's radius.
Oh, height.
It's also a function of height, yes? And it wants to have to be just a function of the radius. So what do I want to get rid of? H. So what do I solve that over there for? H. Good. So whatever letter you want to get rid of is what you solve the tell me equation for, because then you can just replace it.
So 60.
So instead of directly killing H, we sort of in the middle of the night snuggle somebody else. We're like the invasion of the body snatchers. We replace him with a plant monster. If you've ever seen the movie, you should. All right. So if I solve this for H, how do I solve this for H?
Divide.
That's
H
insane.
Over 60 pi r squared.
So now I know H is this, so now I can plug this in place of H. Can you simplify that at all?
No.
Can anyone simplify that?
Oh, yeah.
What simplifies?
They cancel.
What cancels?
The pi r.
Pi cancels, which is always sad.
Doesn't the r
Lose an R, yeah. And then 2 times 60,
is 120.
that's crazy. And then the question, if it was a calculus problem, we'd say, what's the maximum surface area you could get? Or, I'm sorry, in this case it would be the minimum. That would make sense. What's the minimum the surface area could be, would be the question. And then I would take a derivative, find the critical numbers, yes? So it's just like any word problem should be, the hard part should be setting up the function you're going to use. The easy part is then to actually use it. In this case, take derivatives, get the critical numbers, blah, 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 blah. Now, real quick word about this worksheet. The other side of this worksheet, we're not going to get to for a little bit. So let that one just be. Don't lose this dude. I have a whole other worksheet we're going to look at now. It's going to have actual problems for you guys to try. It's crazy. Bullshit.
It's gonna be late. Actually.
All right, let's take a look here. Thank you. So I've given you 2 full examples showing all the steps you would take on these kind of problems. Yes? This one's a silly one because we already know the answer should be a square, and it does come out to be a square. We've done problems like this earlier. This one's a little more interesting. Notice a little thing here. Open top. What's the surface area of this? What's the area of this side? This face right here?
Length half.
Be more specific. X times H. And how many of them are there?
4. 6.
4.
Oh, 4.
Because what's the surface area? What's the area of the bottom? X squared. It's an open top, meaning I don't have a top, which is why I only have 1 x squared, not 2, like in the problem we did earlier. Do you guys understand? So sometimes I will not give you this formula because you should be able to figure it out yourself. So these are just two examples. If I were you, I'd have them sit next to me when I go to do the homework. These are the types of steps you should be doing with the problems you have to do. Yes? I'm not saying it's always going to work exactly. No. But this is the general idea of what you need to get. So what I want you to do you guys notice up in this corner? Most of you guys have a number. One of you has a little star. Yes? Which means they're going to put you, no, I'm joking. You're going to, well, we'll see. You'll be a free agent. You're going to join a group. So what I want you to do is I kind of want you to get started a little bit on this, and then I'm going to group you guys up so you can kind of help each other out. So on the other side of this paper, try to start doing these steps. Oh, God. Sorry. And again, this is, let go of it needing to be perfectly right. Just play with the shit. Just do what you can. Just do what comes to mind. If it's not right now, this is a great time to be wrong. So I ain't got to take points off. Give you a little bit of help with part B. You guys see the most expensive side? Here's what's a little trippy. It doesn't matter which one you call it. It doesn't, because the math is going to make it work out. If that side was 7 feet long, how much would that cost by itself? You guys see the longest, most expensive side? Yes? If it was 7 feet long, how much would that cost me? $105. How the hell did he do that?
15 times.
7 times 15, yes? Now, on your paper, when you drew your picture in part A, do you know how long that is? No, you called it something. Whatever the hell you called it, what am I going to do to figure out the cost of just that side? 15 times W or L or X or Y, yes? And then what's the cost of each of the other sides? Well, they're going to be the same thing, except they're cheaper. So you're constructing a cost function. Just what's the total cost in this problem? You can't construct it until you get part A done. I'm going to give you another minute to work on it, and then I'm going to put you together with other people's. Yes, sir. look at the number that's in the corner, in the other side of the paper? Yes. You guys see the number up in the corner on the other side of the paper? So on this side of the paper, everybody should have a number. The blue side. Where are my ones at real quick? Ones find each other and, well, hello. Who's got a 1 up here? There should be 2 people with a 1 up here. Oh, here we go. Okay. You guys get together somewhere. I'll let you guys work it out. 2s. There you go. 2s. Maybe go over there. 3s. Where are my 3s? Right there. Go back, put Dima back there in the corner. 4s. 4, right there. Go over there with the corner. See, right there. For them. Sorry. 5s. All right, you guys here. You, whichever way you want to go. Let's see who's gonna get up. There we go. 6s. 6s right here. 7s. 7 right there with Layla. Right behind you. And then you are my wild card. You go with anybody. I can pick a group if you want me to, or you can just go with the group. Okay. Help each other out. Call me over if the group needs help.
This is.
So guys, just to make sure everybody's on the right track, I think I got everybody to realize, and let me just use what I think most of you guys are using. Something like that, yes? Some of you guys are using L and W, some of you guys are putting the Y and the X in different places because you're crazy. What's the area from the picture I just drew? What's this rectangle's area? This one.
XY.
XY. And what's the area I told you that I want it to be? 180. There you go. So that is an equation that I can use later. I've written, based on my choice of variables and the geometrical reality, I've written the area here and I've written what I want it to be. So that's what they tell us. Now that I've established how long each side is, I just have to pick one of those to be the most expensive side. So I'm just gonna pick this side to be the most expensive side. It doesn't matter. So if I choose this one to be $15, how much does this side cost by itself? 15 times Y, exactly. $15 per foot times how many feet? That's the total cost for that side. Every other side I'm gonna multiply by 10. So 10x, 10y, 10x. Area cannot be affected by how much something costs. I can't look at a little square and go, I'm going to make it cost $2, and the square suddenly morphs. No, it's just sitting there, yes? So I've got it sitting here. Based on how long I said everything was, I can then figure out the total cost. Now this I can clean up a little bit, yes? 25y plus 20x. So you got to have like 25L plus 20W, whatever letters you used, whatever side you call the most expensive, you should end up with something like this, yes? All right, so as long as everybody got to part B, okay. And if you want to ask me specifically based on your choice of expensive side and variables, I can tell you if it looks good, but try to do part C.
Which is just as simple as taking the second derivative and plugging that number in and seeing if it's positive.
Oh yeah, mine, and this is gonna be neat. Most of you guys, now look. Most of you guys have 25 times 180 in your work, yes? Just the way that I chose where things were for my problem, it's gonna be different, but I'm gonna show you we're gonna get the same answer. This is what's trippy. Since there's variables I chose, the rectangle doesn't necessarily look like this. I arbitrarily chose which side to be the most expensive. The math at the end makes all the numbers show up in the right physical place. But my math could look very different in the middle based on the choices I made. I really hope you're with me.
So most of you guys had 25 times 180 that I looked at. So you got 4,500 here, yes? Now what's funny is some of you guys got 3,600. Maybe that meant between the two of you, you actually set it up differently. So here I get 3,600 y. Most of you guys got 45 because you actually replaced this variable, yes? Okay, just stay with me. We're good. You're not wrong if you had a 4,500. You're fine. So over here, find the critical numbers. So I take the derivative. I'm going to write this a little differently. This makes it the derivative a little easier to do. So I get 25 minus 3,600 y to the negative 2. One critical number is y equals 0, because that makes this undefined, but physically that would make no sense. That would make the cost a minimum if my rectangle did not appear. So that's kind of a dumb way to do it. Actually, that would make, to be honest, what would happen is I would put one fence that kind of just goes. Anyway, forget it. The other way is to set this equal to 0. And I like that a lot of you guys some of you guys got to this point here, and you're like, what the hell do I do, Jeff? Well, just do what it says. What does that say? Flip. So if I flip both sides, and then take a square root, normally you have to put plus or minus, but we know y is a physical length, so I'm not going to let it be the negative answer. 3,600 divided by 25 is 9? No, that doesn't make sense, Jeff. Did I go the wrong way? What is 3,600 divided by 25? It's times 4. 36 times 4 is 144. So this is 12. I get 12. Most of you guys got 15, correct? What's 180 divided by 15? 12, yeah. So you guys solved for the other side than what I solved for. The math don't give a shit. I desperately want you with me right now. If you got 15, tears for you. You just found my x side. I found my y side. Who cares? Is my cost function a variable, a function of my y? Yes, that's why mine looks different than yours. If I throw 12 into this, what do I get here? 25 times 12 plus 3,600 divided by 12. That'll be, you could do it, Jeff. 300 plus 300 is $600. Is that what you guys got? $600? Okay. I love you guys. Do you agree with me? Now I was going to do this anyway, but I didn't think I was going to do it this way. So most of you guys got 15, yes? And your variables might have been turned around, or maybe you had L and W, but we all got 15 feet for one side, 12 feet for the other side, yes? Is everybody with me? I want to go, so that's the dimensions. Did I ask for the dimensions? No, so you didn't have to find these. I just asked for the minimum cost, and that's what that is. Now, to make sure it's a minimum, what would I have to do? You can do it. How do I check to make sure this is the minimum?
Use the second derivative test.
Second derivative test. So what's c double prime? This is easy. That goes away. Negative 2 times that would be 7,200 y to the negative 3. And if I plug a positive y in, what is this always? Positive. So it's a minimum. Hey. Let me stop for a moment. You guys are all with me. We have found a candidate for minimum cost was y equals 12 for me, x equals 15, or y equals whatever the hell, 15 for you. How do you double check to make sure that critical number is actually the location of a minimum? Second derivative test is a great idea, unless the second derivative is horrific. In which case you just do a first derivative test. Yes? But again, in the real world, you don't want to give the answer that makes things worse. You want to give the answer that makes things better. So you want to take, did I actually find what makes this good? And I did, thank God. Alright. Let me stop for a moment. Do you guys see how what they tell me is completely distinct from what they ask me? That is one big thing I wanted to come out of this. Now, do they work together eventually? Shit, yeah. Yes? But this is all, the first thing was just physical, just lengths. The second thing was cost. That's when you put that together. Okay. When I see a problem, and it says, like this one said, minimize cost. Right? Minimize cost. That means I want a cost function. If it said maximize the number of potatoes you grow, then I want a potato function. And then I can attack with calculus. If it says minimize the amount of feed you have to give to your chickens, then I want a chicken feed equation that I can then take a derivative of. Do you guys follow what I'm saying? So it kind of gives you a target from the beginning. Whatever says minimize, maximize blank, you go, I need that function. And that's kind of like in the back of your head the whole way through. I need to make that function because then I can attack it. Okay, maybe, Jeff. One little thing on the side. This is completely on the side. Do you all agree with me this is not a square? If not, then see me after class. Okay, so this is definitely not a square. It's 12 by 15. But watch this. This is so cool. If I come back to my original thing, this is 12, 12, 15, 15. And I said this was the more expensive one here, yes? This side I said was the more expensive side. And if you look at it, your more expensive side came out to be the smaller number, which makes sense because they're trying to minimize the cost. Okay, so this would be 15 times 12. This would be 10 times 12. This would be 10 times 15, 10 times 15. What is 100 doing there? I don't know. This is 15 times 10 is 150 plus 150. There's 300 total dollars in this direction, yes? This is 120, this is 180. There's $300 in this direction, yes? In terms of cost, this is a square. That's trippy as shit. You don't have to do anything with what I just said. I'm just sharing with you something neat that I've noticed. The answer is physically not a square. Do you guys agree? But in terms of cost, there's the same cost this way as there is that way. So there's still a square in there. Do you have to know what I just said? No. Do you have to find a square and everything? No. Can you forget what I just said? Totally. It's not going to hurt you. I just want to share it with you. So let's do this. Before we do number 2, we'll take a break. Yes? Come back at 5 after. I'm going to try to let us out a little earlier. So come back at 5 after. If you have any questions about anything, just hang out after. During the break, I can help you. Go take a break. I'm sorry, do it again? Maybe. I don't know. So he keeps saying Pythagorean theorem, yes? Do you guys see why he's saying that? Or has he just gone insane? Proximity to me sometimes causes that. Why is he saying Pythagorean theorem? Where's the triangle? You can make a triangle, yeah, because the whole idea of the distance between these two, if only they were across from each other, that'd be easy as shit. But if I do go across and I go, oh shit, it's up there, and I go up, I've just made a triangle where the hypotenuse of the triangle would be the answer. So there is a distance formula that you could memorize, but it always struck me as dumb because it's just Pythagorean theorem. Does anyone remember the distance formula itself? Or are you like me and you're like, why would I throw more shit in my head? No. That's the dirt formula for driving down the road a certain amount of time. This is the distance between 2 points. So,
y2, yeah, y2 minus y1.
Yeah.
x2 x minus x1.
So how long is this side? It would be 2 minus negative 3, yes? Do you guys get it? It's 2, what am I doing? Negative 2, you could do better, Jeff. 1 minus negative 2, there we go. I got ahead of myself. This side would be the difference in the y's. You guys cool with that? You could just see, how high did I go up? 1, 2, 3, 4, 5. Which is the difference in the y's? How far did I go over? 1, 2, 3. Which is the difference in the x's. So this is like finding slope, but instead of dividing one by the other one, I square them and add them. Take a square root, yes? So the distance formula, so I almost don't care about these specific points. But in this problem, it would be
The squared distance would be 5 squared plus 3 squared. And then you could, so the squared distance would be 34, yes? And then I take a square root to figure out the distance, okay? Do you all agree that if I minimize the squared distance, I must have then minimized the distance? I'm thinking of a positive number. If you minimize the number squared, then you've minimized the number. I don't know if you guys are really with me. If I minimize the square distance, I have minimized the distance. Because I would just take a square root. Yes? So what does that have to do with us, Jeff? Well, we have to do calculus. Is it easier to do derivatives to separate terms or to something that's inside of a big ass square root?
Separate terms.
Separate freaking terms. I don't want a big ass square root because that would be a gross big chain rule kind of thing, yes? If I have a choice, I am choosing that way. And we have a choice because we're the humans. We made this shit. So if I want to minimize the distance between 2 points, I don't have to solve in square root and then do the calculus to that. Oh my God. Minimize the square distance, and that'll be your answer. So, okay. Let's take a look at this problem here. This one's neat. I love this one. If I have 2 points, I could do this. Yes? Does anyone see 2 points on number 2? Is this that same worksheet we were just working with? Yes?
Yeah.
Do you guys see 2 points on this one?
You can make
Yeah.
2 points.
Do you guys see 1 point?
Yeah.
Yes.
What is it?
2, -1.
Beautiful. There is a second point.
Oh, the vertex.
No?
No,
What
wait.
do you create?
What's got to be true about the other point? Where's it got to be?
On the
On
X.
that.
Okay, good. So what do they tell me? My point is on this, yes?
Yeah.
So do this on squares?
They tell me
Oh, -1, 0.
y is x squared minus 1, and they ask me distance between xy and 2, -1. So do you agree that that's just some arbitrary point? Y'all with me?
Yeah.
But what do they tell me has to be true about the elements of that point? The y piece must be x squared minus 1, yes? So what points am I actually working with? If I use my tell me inside of what they ask me, what point is this? Yes, x comma x squared minus 1. So those are my 2 points. Do you understand? If I make x 3, I get the point 3,8, and then I could do distance formula. If I make x 4, I get the point 4,15, and then I could do distance formula. Do I have to tell you a value of x first in order to do the distance formula? No, because I'm going to do the same damn thing every time, yes? How do I do what's distance squared then? What's the difference in the x's?
2.
2 minus x.
Sure, we can do 2 minus x. And what's the difference in the y's?
-1.
I would probably go the other. It doesn't matter. So you could do x squared minus 1 minus -1. Is that cool? It's the eternal struggle of mine. What we just did is we did the process with a point I know and a point I don't know. The process doesn't give the first shit what I'm using it on. If I have 2 points, what can I do? Find the distance between them. I can't, I just can't. Doesn't matter if one of them I don't know. No, if I have symbols for it, I just do the same process. So there's a structure in mathematics that we feed specifics. I have less specifics for this problem. I don't care. I can still do the process. Can you guys, well, how does this simplify a bit here? Don't go too far. I'm not gonna foil this out. You'll see why in a minute. What happens here?
The 1s.
-1 minus -1. Okay, so then I get x to the 4th. If I'm trying to minimize this, I don't have to take a square root. I don't. The calculus would get stupid hard, and it would be completely unnecessary. If I make the square of a number as small as possible, I have made the number as small as possible. Does that make sense?
No.
If the smallest square I can get is 25, what's the smallest number then? 5. So if I minimize the square of something, I have minimized that thing. And let me be really careful. In the background of all this is the fact that it's got to be positive. Yes? Because we're talking about distance. If you have negative, if you're 4 feet away from me, you're somehow inside me.
Quaid.
Okay. Nobody ever gets that reference. So what I'm about to do is going to freak you out a little bit. Do you guys see that square?
Yes.
It's not really there. This is a d squared function. So I'm going to take the derivative of this. I don't have to do implicit differentiation. The function's name is d squared. So what's the derivative of this side? You'll see why. Do you see why I didn't FOIL this out?
2 times 2 minus x. Times
Good. Chain rule. Yes. Plus.
4x is cubed.
Good. Yes. Oh, I think I'm remembering something with this problem. Damn it. I never will remember to change this problem, but it'll be okay. So I get 4x cubed plus 2x minus 4, it looks like. Let me make sure, let's see. Minus 4 plus 2x, yes, okay. How do I find my critical numbers?
so it equals 0.
Set equals 0. This is where things get bad. I could divide by 2, yes. That doesn't really do much for me. And if I remember correctly, does this have a nice answer? Let me think. What did I just say to myself? Yeah, this might work. Let me think. Well, Jeff, write it down. So what I'm trying to do in my head is synthetically divide. 2, 2, 2. No, that won't work, will it? It might not have a nice answer. Ah, it sucks. I always forget to change as well. If that was a square, we could factor potentially. We could use quadratic formula. Do you understand how we're at a point now that I have to use synthetic division to try to factor this? Or I could plug it into the calculator, which is kind of like going against the idea. I always forget to change this problem. I need you guys with me. If that was a squared, could we not use quadratic formula?
Yeah.
Yes. That's a cube, which means the only way to factor it would be to try to use like synthetic division. Yes? And I don't want to spend all day. Let me try one more thing. If I try 2, that would be even worse, I think. Well, that would be even worse. Negative 1 wouldn't work. Damn it. So it's got to be something gross. Arg. Okay. But what I would do from here is I would try to factor this or get the answer somehow. That would be my critical numbers. And then I can check to see if they make it max or min. In this case, I'm trying to minimize the squared distance. So let's do this. Let me grab this kind of problem from the homework section. Someday I'm going to remember to change that. Here we go. Perfect. Like number 26. And let me show you visually the idea of this. Do you guys see number 26? Y equals square root of x. Can you guys take a minute and give me a decent little sketch of this? Everybody try to sketch y equals square root of x real quick. Just a decent sketch. Show me some scale. Show me some points, right? Right, not too hard, right? It's like a parabola that had a hard day, fell over. Yes? 0, 0, 1, 1, 4, 2?
Yeah.
Now where's 3, 0? Because that's the other part of this problem, right? 3, 0? It's right here, yes? Do you guys agree that it is not straightforward to find what point on this is closest to this? It's not this one, because as I go this way, it curves down a little bit. So I bet you anywhere, it's somewhere in here. Do you guys get that? Do you see that idea? The closest point on this function to this is not straight up and down because it's curved further away as I move out. So it's got to be, if I move too far over, then it's too far away. It's got to be somewhere right there, maybe. And is that an easy point to see? Can you just see it? Whoa, no. I need you guys to see the concrete idea behind the problem. I have a function. Why would this be important to know? Has there been recent, like in the last 10 years, have there been objects that scientists have said, oh, that's going to come close to us? Have you guys been paying attention at all? Do you know that several times there have been asteroids and such that have come relatively close to the Earth? Isn't it good to know how to tell something's trajectory and what the closest approach will be? Because if it gets close enough, it might even be caught up in our gravitational pull and then become another moon. Or it's going to hit us and we're going to have to send up Bruce Willis and whoever to go blow it up. I guess, how are you guys doing? Are you guys doing all right? Behind every problem is an application. I have to live both worlds. I want you to see the math as for the math. And we go, oh, you could use this for this, but it almost doesn't matter. The math exists on its own, and then we find a use for it. Okay, so everybody get the idea? I can't just go straight up and go, that's the answer. Because if I go a little bit back, it's curved down a little bit. It's probably going to be a little closer. If I go too far back, well, that's obviously too far over. So there's a sweet spot in the middle. So a lot of these optimization problems, you can get it from the word optimization, trying to find that sweet spot. All right, so how the shit do we do this? Well, what's this point right here?
2.8.
XY.
I just love that.
Oh,
I gotta take a drink. You're like, why even do it, Jeff? I can tell it's 2.8. What's wrong with this man? Okay. You're good, you're good, you're good. That just was funny. Sorry, what? Here, you ready? It's XY. Yay! Now what do they tell us though about that point? Where's that point live?
On
Y equals. All right, so if I use what they tell us in what they ask us, what's the point then?
X, right.
There you go. Now, do I have 2 points now?
Yeah.
And I want to find the what between them?
Distance.
Distance. In fact, the square distance, so I don't have to do freaky square root calculus. Would it work? Yes. Would it be way too much work? Yes. So don't do that shit. Can you guys try to set up the square distance formula and see how far you can get? This one's really nice. This one should have a nice answer, I'm thinking. Come on, bye, little dude. Let's see. It was even further back. That's neat.
Hold on. You know what?
That's not what I expected. Okay. It's probably because my picture sucks, but. Oh, I see what I did. That's what I did.
You took the square root. Remember, this is you're not taking the square root. What you're supposed to do is
Just the derivative.
just the derivative, because that's the formula. of this.
That's better. That makes more sense. Okay, now I feel better.
One of our
Look at
You
it.
guys see how that radical becomes really nice because
Cancels
square root
out.
of x minus 0 squared is makes sense.
So we have a formula.
No.
That's the formula, yes? That's just Pythagorean theorem. This side squared plus that side squared is the distance between them squared. You with me? So I'm going to use, let's see, let's talk about x's first. So x minus 3, the x of one, the x of the other one, plus the y of one, the y of the other one. And again, you start to realize when you get a little further in calculus, don't make the mistake I made and have the square there. I don't need to FOIL this out because its derivative is going to be stupid nice. So I'm not going to waste time foiling this thing. What do I get when I take derivatives?
2x minus 3.
Plus. Is that cool? I just distributed the 2, all right? 2 times x minus 3, 2x minus 6 plus 1, yes? How do I get the critical numbers, which is where the minimum might occur?
Equals 0.
So you get x is 2.5, yeah, so 5 halves. And if you look back at my picture, I did pretty good. I mean, 2.5 is about right there. I was pretty close. Especially if I if I make my dotted line slanted. All right. I guess it's roughly in this place that we thought it might be. If I go this way, that's dumb because then it's curving away from me. If I go that way, it makes more sense. Too far is too far. Okay, maybe. How do I know that? Go ahead.
So that's the point, but what if it was asking for the distance, we should just take the square root of 2.5?
No. X is 2.5.
Yeah, so like.
Now you would plug it into this formula
Okay.
and then take the square root of that.
Okay.
The distance isn't equal to x. That x value leads to the point that would be the closest. So what did the problem actually ask for? Find the point. So have I done? Have I found the point? How do I find the point?
Plug it in.
Yeah, 2.5 square root of 2.5, whatever the shit that is. It's not 0.5. Huh?
You're not gonna try to do it.
Oh, goddamn. Don't do that to me. It's like 1.57.
1.58.
Damn it. I will retire. I'm terrible at my job. I'm sorry, guys. Okay. Yeah, sorry. There's like little tricks you could do. I don't care. I'm not big into being like a mental calculator dude. I hate that shit, but there are little tricks you can do. Okay. Is everybody semi with me? So I want you to notice this one definitely felt different than the cost one we just did. Big time. It was less complicated. So the tell us, ask us is really thin here. It's like you don't even need to think of it this way. Because that point is this. But you can think of it as tell us that it lives on this thing, so that point must become this if I use what they tell us in what they ask us. Blah, blah, blah. So let's try one more of these, and then I want to talk about the next section a little bit. Yeah, I want to try this one. Is it that one? God, that might be in your homework. Urgh. That's great. You guys upset if I do one of your homework problems?
No.
I think this is one I signed, but read through 36. By the way, this is a favorite kind of problem of mine. Can you guys try to draw the situation? Where did I put all my paper?
Oh, tomorrow, yeah, I'm not school tomorrow.
No, we don't.
Oh, yeah, because we celebrate July 4th.
Yeah, tomorrow is July 2nd, so we're celebrating the 4th of July tomorrow.
Woohoo.
So you could come to the college, but it's going to be shut down. So it's up to you.
Everything has to be.
Okay, so they tell us.
Yeah.
This one's trippy.
It's a
They
normal.
tell us. What do they tell us?
They told us.
Y equals 4.
What? Oh wait. Can we factor it out to just get the x-axis? I mean to get the.
No, we'll get there. they tell us that our rectangle has to have corners on that parabola, correct?
Yeah.
All right, so this is all right, we'll get there. So they tell us
Oh, I remember doing that.
that our rectangle has corners.
We can't see.
I know, because I do have the book here somewhere. Oh, I closed it, so I want to look at this. On y equals 4 minus x squared. They're trying to find, and they ask us area. So what this involves, can you draw this? Can anyone tell me anything about this parabola? Anything?
It's a down arrow.
It opens down, kick ass. Somebody tell me more about it.
You can factor it out to get the x-axis.
Do it again.
Base is at 0, 4.
The vertex is at 0, 4. Yes? Because it hasn't been shifted left and right, so it must be still like this. It's just been turned around and shifted up 4. Can somebody else tell me the x-intercepts?
2 and negative 2.
Good. 2 and negative 2. And I can't remember this explicitly said. Shoot. I don't remember. But we live in the first quadrant, I'm pretty sure is what they told us. Yeah, the base is on the x-axis, yes? Now look. Now just to show you real quick. I could draw a rectangle like this, I could draw a rectangle like this, I could draw a rectangle like this. Do you guys see what I mean?
Yeah.
Where the corners hit the parabola, yes? And that's the changing over time. So somewhere in there is a sweet spot that makes that rectangle as big as it can be. You guys get that? So in almost every problem, it's all about a sweet spot. If I move on the y equals square root of x, there's a sweet spot that's closest to this other point. So the whole point there is to try to find that. So over here, I'm just going to pick somewhere for it to be. And I tried distinctly to make it not something specific so my poor little brain doesn't think that the answer is 1 or something. So what is this right here? Don't give me an estimate, because I just drew this in arbitrarily, so just to help you guys out, this is x. So what's this?
Y.
Y, that's crazy. So what's the area?
X, Y.
Now how do I use what they told us
You can
in what they asked us?
plug in 4 minus x squared.
Yes!
Y.
I know y must be 4 minus x squared for any point that's on this parabola. And therefore, anywhere I have a y that's on that parabola, it must be 4 minus x squared. All right, let me stop for a minute. I'm constrained. I can't make x and y anything I want it to be, because if I change x, y changes. And you can literally see that if I start here and go up, now my y is smaller than it was before. If I start here, my y is huge. There's also an inherent restriction on x. What's the biggest x could be? 2. If I go outside of there, the whole thing goes crazy. Okay. So how do I rewrite this?
X, 4 minus x squared.
And then what do I do with that crazy thing?
Derivative.
I don't factor it yet.
Derivative.
But you gotta find critical numbers, which involves me first taking a derivative.
4 minus
4 minus 2x.
Do you guys start to get the flow of this? Now here's what kills students. You guys want me to show you an example of every problem you could see, and that is impossible. That is completely impossible. Let go of that hope. I can give you some traditional classic problems. I can make sure to kind of show you some of what you will see. But I gotta leave it open to you hitting one that's not something you've seen before. How do you attack it? What do they tell me? What do they ask me? Will a picture help? Can I set up the relationship? You've got to start buying into that structure. And the structure works no matter what situation I'm in. So a lot of what students want, I cannot give you. Could I make the class so that I could do that? Yeah, I could constrain the kind of problems I give you, and I could totally not prepare you for your next step. I have chosen not to do that. That makes this class harder. Yes, it does. Not inappropriately so, but very appropriately so. I don't know if you guys would. Okay.
You're like, sorry. You're like, that didn't help me, John. All right. What do I do now with this? Why did I take a derivative? What am I trying to find?
The critical points.
And I find the critical numbers by, yeah, there's nothing that makes this undefined. So I'm going to get slightly gross answers, but that's too bad, right? I would get x squared equals 4/3. Is that cool?
Yeah.
Add this over, divide by 3. So I get x is 2 over rad 3. Plus or minus, you see in the problem how it's that way, but I've defined x to be over here, and that would just be a mirror image. So 2 rad 3 is good. And what did the question want? I forgot. Damn it. Close my book.
The largest rectangles.
Sorry. I love you guys. Did it want the...
I wanted the largest rectangle.
What is the largest possible area? So it wants the area. So how do I get the area? Can I get the area from this knowledge?
Yeah.
Yes, because I have a formula with the area. Actually, this is even better. That involves x, yes. So I can just plug that 2 over rad 3 in. If they wanted to know the dimensions, what would I do? Do I know x?
Yeah.
The other dimension I'm missing is y, and I have a relationship that I can just plug it in there, yeah.
Wait, why don't you use the negative? 2 over rad?
I mean, you could see visually just as that mirror image. So, I mean, you could say it's plus or minus. From my picture, the way I drew it, I'm considering this to be a length in this direction. Now, you could also say this whole thing, and actually I've made an assumption here. And I mean, nobody balked at this, and I didn't even think to mention this. Is that really the area of that rectangle? What's
No.
missing here? What should be here? Yeah, that's half of the area, correct? Let me see if you guys understand. If I put a 2 here and I take a derivative and I set it equal to 0, won't that 2 just cancel? If I maximize half of it, didn't I maximize the whole thing? Okay, so that's kind of like what I did that for. Let me see if you guys pull this. Do you guys agree with me that the actual area of this rectangle is 2xy? Do you guys see that? You guys with me?
Yeah.
So I'm telling you, I'm a dirty liar. Look at me. I lied at you. Look at me. I lied to you. God, I suck. And then if I do this whole thing again, and I replace y with this, and then I distribute, I feel so bad. My voice is cracking. I'm so sorry. I'm here to apologize. And then I take a derivative, and then I set equal to 0. Well, I get the same stupid look. The 2 just goes away. So mathematically, this happens. How did I minimize the distance? I didn't minimize the distance. I minimized the square of the distance because it made my calculus easier. This wasn't that big of a deal, but it's just such second nature. I didn't even think to say something. But if I minimize half of the area, I've minimized the whole area. Either way works. You see, I get the same answer, don't I? Okay.
Maybe.
So there's going to be a decent amount of graphing or making a picture. That is a really good idea to anchor yourself visually as to what's going on. It's not a bad idea just to play with the idea of the problem. If I change where I put my rectangle, you can see how the area is changing. So it kind of makes more sense as to why the problem even is a good one to ask. Okay. And so if I want to get the area, I would just plug this in. 4 times this minus this cubed. That's just gross. What's that? 4 minus 4/3. What's wrong with me? 8/3 times that would be 16 over 3 rad 3. Yeah, whatever the hell that is. So just plug that in on the calculator and get something. Okay. So unfortunately, I can't do an example of every problem you could see, because the problems you could see are any, period. But what do I look for? I look for by constraint. What do they tell me? What do they ask me? Minimize blank, maximize blank, make this the smallest, make this the biggest. That's the function I want to create, and I want to use what they tell me to get rid of one of the variables and what they ask me. Calc 3 is multivariable calculus. We're not in Calc 3. So I don't want multivariables, thank you very much. I want to get rid of some of them. Okay.
Okay, I'll let you guys try that out. I want to talk a little bit about section 4.8, then we're going to talk about 4.9, and then we're going to call it a day. Do you guys remember what I said about 4.8 before?
It was kind of optional, the homework.
Do it again?
The homework was optional.
Well, yeah, I'm going to make 4.8 extra credit.
And something about word problems.
No, it's not word problems. It's actually a beautiful little algorithm. I am going to talk about it because, real quick, did I, wait, 4.8 is the right section for this, right? 4.8 is Newton's method. I want to make sure I'm talking about the right. Yes, okay, 4.8, Newton's method, beautiful. Have you guys ever used your calculator to find an x-intercept? So real quick, if I put in here x cubed minus 6x plus 2. All right, do you see how many x-intercepts I have? I have 3 of them, yes. Now, watch how to find an x-intercept. I'm going to pick one of them. I'm going to pick that one in the back here. I'm going to find that x-intercept. If I had to guess, it looks to be negative 2.5.
Just move your
It probably isn't that. No, if I trace it, I'm going to get an estimate, but I'm not going to get the exact answer. Because see how much it jumps around? Yeah. So here's what I do. What's the name of an x-intercept? Does somebody know another name for the x-intercept? Roots. I love it because math people are very simple people. We're like,
That's the ground and then the roots.
okay, so we call them roots. That's pretty much why. That's a slightly drunk history of it. Does anyone know another name? What does the x-intercept do to the function? It makes the output. So we call them zeros. We call them so there's 3 things. The x-intercepts are the same as zeros, are the same as roots, or roots, however you want to say it. So if I go to calc, everything in this top row is about graphically. So if I want to calculate something graphically, I go to where it says calc in the graphical row. What do I want to calculate? I want to calculate the 0. Now watch what it wants from me. It wants me to give it a left bound for the answer. So what I'm going to do is, I'm going to put my cursor as close as I can to the answer, and go to the left a couple steps. That sets up a wall. It wants a right bound. So I'm going to go to the answer, go to the right, set up another wall. So now I've told the calculator the answer is in between those 2. What it's doing is it's going to run an algorithm in the background, and if the algorithm takes it out of those 2, it kind of adjusts it to bring it back in. That's why I give it walls, or else the algorithm could actually make it go to infinity, and then the battery starts to smoke. Bad things happen. The last thing it says is guess. It wants me to give it a guess. I'm going to put my cursor as close as I can, and then it does its magic, and it gives me the answer. Now that was pretty fast, yes? I emailed TI, and I said, hey, I teach this. I teach the whole algorithm. I know you guys modify your algorithm. Can you give me an idea of how you do that? Right, because I wanted to share that with my students. This is a few years ago. So I got an email back saying, we don't know if you're from HP. You could be a spy. We're not going to tell you anything about our algorithm. I'm like, what? So anyway, so now I got that to tell instead of the actual thing. The algorithm, and I'm not going to spend a ton of time on this, but I am going to show it to you. It is the algorithm that it uses. They've just modified it to make it a little more robust because it will break down sometimes. And this is such a cool idea. So watch this. And I don't blame you if you don't pay that much attention, but just watch. You don't have to do this work, so just sit there and watch. You're fine. It's extra credit, yes? If I have a function, and I got an x-intercept right there, yes? Let's say it's at A is the right answer. We don't know that. We don't know what the answer is. And I pick a guess at x1.
like that.
Sorry?
No.
Yeah, I don't know where A is. I'm just guessing. You with me? So I pick an x1. I don't know. I feel like I'm pretty close. Okay, because I've drawn a rough sketch and I feel like it's pretty close to the right answer. that's not correct. Because when I plug it into f, what do I get? I get here, don't I? I get f of x1. Yes? Is that cool? Which is obviously not 0. Is everybody semi with me? Now this is such a cool freaking idea. How do I make the tangent line at that point? No, not just draw it in. How do I create the formula for the tangent line? Like I can draw it in, roughly. And do you see how that gets, now this picture is, I kind of, do you see how that gets almost the answer? Okay. I'm still a little off. If I zoom in, I'm still not quite right. But you see how if I make the tangent line and see where that hits the x-axis, that should get me closer to the answer. Depending on how freaky my function is, and that's why they modify it. And that's why they ask for walls. If my function is really freaky, it's like, please give me little walls to live in so I know about where the answer is. Okay. Maybe you guys are with me, maybe not. This is the function. How do I find the tangent line? Now, I know some of you guys freak out because I haven't given you what the function is. I haven't given you any numbers.
Y minus f of a.
Well, what do I find first?
The derivatives of just f.
Yeah, so I figure out f of a, like you said. I figure out f prime of a, yes? And not f of a, though. Be careful. What am I building this around? x1. A is the answer that I don't know. All right. So then my tangent line, my linear approximation would be f of x1 plus f prime of x1 times x minus x1. You guys with me? That's y2 minus y1 equals m times x2 minus x1, or x minus x1, sorry.
Why wouldn't the f of x1 be negative since you brought it over? Oh no, because it's already negative.
Yeah, it's y minus y1, yeah. Okay. It's just f of a plus f prime of a times x minus a, the linear approximation, yes? Are you guys with me? What do I want to do with that tangent line now? Considering I'm trying to find a, I want to find the tangent line's what?
0.
I want to find its x-intercept. It's 0, yes? So how do I do that?
Set it equal to 0.
Set it equal to 0. What am I going to solve for?
X.
Sorry? Yeah, I'm going to solve for x. You're right. So watch this. I just didn't like the way you said it. If I solve it, and let me do this in steps. How do I solve this for x? I'm going to subtract that. Yeah, I'm not going to distribute because I always hate distributing when I don't need to. So negative, yes. Divide by this thing. And then the last thing I'm going to do ever is I'm going to add x1. That gives me, believe it or not, what that gives me is x2. Do you all agree with me?
Oh, because that builds the other wall.
Like if I would have picked my x1 was here, the tangent line would have brought me over here. Then that would have been x2, and I would have done it all over again, and the tangent line would bring me closer. That would have been x3, and I would have done it again. So what this process does, this is called Newton's method, by the way, because Newton supposedly made this method. More than likely he stole it from somebody. Who knows? The history of math is weird. Well, what I actually end up doing is, I end up doing this over and over, so then x3, I would plug x2 into all this. And every time I do this, if my function isn't behaving badly, I'm going to get an improved thing. So what does the calculator do when it tells it to find a 0? It effectively does this, it just does it so fast. It takes a guess, it takes our guess, that's x1. It takes our, didn't ask us for a guess, that's x1. Runs it through the process, now it's got an x2. Runs it through the process, now it's got an x3. If at any point it goes outside the walls, it modifies the initial guess. And that was what I was curious about, is how do they modify? I just wanted to know, I wanted to show my students, and like, screw you. It's okay if you're not completely with me, because obviously you don't have to do this, it's extra credit. But I have to show you this because you're getting to the math
where you can now be told what the stupid calculator does. Somebody had to know how to do it. We didn't just make it and have a ritual and the magic imbued it. The black box tells me the answer now. No, we had to know how to do it and then program the dumb thing. So part of you, I'm hoping, is like, how does it do that? There's a way. There has to be a way. It's not just magic. Okay. So that's 4.8. And if you want to try the extra credit out, I could actually post the handout that I have for this. If somebody wants to remind me at some point, if you want to email me. If you don't want to try the extra credit out, you're fine. I understand summer's quick enough already. Well, I do extra work. I understand. So before I let you out of here, and I'm going to let us out a little bit early, just because I feel like we all deserve it. 4.9 is where we're officially doing the bonus question we went over earlier.
The plus
4.9
the
is,
plus C one.
yes, 4.9 is anti-derivatives. So here, you ready?
Are those just integrals?
Huh?
Aren't those just integrals?
We got a ways to go before we show that. Integrals are finding area, and then we have to prove that it's connected to this. But, yes, just not yet. All right. In fact, we don't know the word integral yet. So, for example, let me give you something that's not a polynomial. Actually, let me give you a more complicated polynomial. What if f prime was 7x? So see how this is an antiderivative. The question is, undo the derivative. Hell, I understand why you say that. Forgive me, Ram, I'm going to use your example just for a second. A lot of students say exactly that. I'll get a lot of students tell me the answer is x to the 7th. But what's the derivative of x to the 7th?
7x.
So the power is what guides everything here, because what rules the power rule is what the power is. Right? The n comes down, goes down by 1. So I'm currently at a first degree, so where must I have started?
Second degree.
So I write that part first. Now, what I'm writing right now is not the answer. But I'm going to write it because I know it's part of the answer. What would have gotten me to 7 then? I would have had a number there that when I brought the 2 down, it would multiply by 7, so 3.5 or 7/2. Yeah. Plus C.
Plus C is plus constant because if you have like 200.
So real quick, actually here, let me give you one more of these, and then I'm going to try to make a rule out of this. What if I had, oh, you're going to love this. What if I had 4x to the 1/2?
1/2 x to the 1/2.
What would the power have been?
We're gonna divide the 1/2 divided by 4.
Don't go there
3
yet.
over 2, 3
What
over
would the power have been?
3 over 2.
3/2. Does everybody see that? I'm doing derivatives backwards. So when I do a derivative, I subtract 1. So when I do an antiderivative, I add 1. And here's the neat thing. When I do a derivative, subtract 1 minus 2. When I do an antiderivative, add 1 plus 2 is 3, put it back over 2. Isn't that stupid? Every fractional power is easy as shit to add 1 or subtract 1. How do I figure out what should be here then?
4 divided by 3 over 2.
Yes, or even better, 4 times 2/3. How do I divide by a fraction? I multiply by its reciprocal. So this would be 8/3, x to the 3/2, plus c. How do I check that?
Go back.
Derivative.
Take a derivative, yeah. If I take a derivative, what happens?
You're gonna
3/2 comes down. Power goes down by 1. The c dies. 3's cancel. 8 divided by 2 is?
4.
Hey, all right, so antiderivatives are beautiful because they're a little tricky to do because you think backwards, but then how do you check it? You do the easier thing. You take the derivative, and then you can quickly see if you made a mistake. And you know this was coming. We taught you addition, and then we went, now let's do subtraction, right? We taught you how to do this forward, now we taught you cosine, and then we taught you inverse cosine. Ooh, shit. So math has always got to be able to go both ways. We can all be jealous, but it goes both ways. Thank you. What about something a little more general? Where would this have come from? So I'm going to make a rule now.
X to the n to the x n.
No, you're doing the derivative. I want the antiderivative. What would the power become?
X
N plus
plus
one.
N plus 1.
1 over n.
There you go. That's it. Which is why this was x squared over 2 times the 7 that was there. So it's really just make the new power, divide by the new power. Make the new power, divide by the new power, which is multiplied by the reciprocal. Yes? So the power rule for derivatives is easy as shit. So it should make sense that the anti-derivative power rule should be relatively easy as shit because it's just doing what we did backwards. How you guys feeling so far? That works for any n except for 1. Can somebody tell me what n that does not work for?
0.
0 is fine.
-1.
-1. Because what would happen if n is -1?
It would be 0.
0.
Be undefined. So what kind of function is n? If I make n -1, what function do I get?
1 over x.
And what is its antiderivative?
That's 1 over x.
Now here's, all right, I like the plus c, but it's still not right. There's something wrong there. So do you see why? So mathematically, why can n not be -1? Because then I would have undefined.
It would be.
But we know that 1 over x, we know where that comes from.
It would be natural log of x plus.
No.
So like in parentheses.
No,
Is it gonna be
that would be worse. That wouldn't be right.
Oh no, yeah.
I don't know if you guys remember. What's the domain of this?
Everything but
Everything except 0. What's the domain of this?
Everything but negatives. Right?
I kind of like the way he says.
0.
Everything except this infinite number of things. So everything above 0, yes?
Yeah.
Do you understand how the domains can't change just because I did like a derivative or something? It's got to.
Yeah.
The derivative and the antiderivative are all about what's happening, what's the function doing, and if it exists somewhere and then it doesn't exist here, it doesn't make any sense. There. So the antiderivative of 1 over x is the natural log of the absolute value of x. That is one of the easiest things to forget as a student, and I'm pretty sure when I taught you the derivative of this, I went over this. And explained the whole thing about the domain. Yes.
Wouldn't 0 work for the bottom?
So I'm sorry.
0, because for the top one it can't be 0, but for the bottom, wouldn't 0 still work?
Well, no. What's the natural log of 0? Undefined. It's an asymptote there.
Yeah.
Absolute value makes it go like this.
Yeah.
Yes. Because now it exists on both sides. Okay. Couple more, and then we'll get out of here. Here's a nice, easy one. Well, let's see if it's easy. You guys ready?
Negative cosine?
Kick ass. Negative cosine plus c. And this is what sucks. This is like learning how to drive stick, because I can always see the smoke coming out. The gear shift is freaking out because now we got to go in reverse. Yes? And from derivatives, derivative sign is cosine. But antiderivative, what would I take the derivative of to get sine? Well, it can't be cosine because the derivative of cosine is negative sign. So that must have been a negative sign to make the sign positive. SIG and SINE or something. But how do you guys feel out there? So that's a relatively easy antiderivative, but it's also a relatively easy mistake to make because you got to think backwards. What about this? Oops. Tangent. Okay, so now you guys are starting to understand. The better you know your derivatives, the easier antiderivatives have to be. Yes?
Yeah.
So let me show you notation, and then I'll actually let us out here. So, what if my function is this, and I want to know what's one we haven't looked at yet? I got it. Ooh, let's do this. There we go.
Sorry.
Sorry?
I thought you, what's the antiderivative of e to this stuff? Is it still e to this stuff?
Yeah, see, E is the MVP.
Oh,
E kicks ass. But I'm doing 4 to the stuff just to be an asshole. Notice I didn't put a prime here, yes? But I want to take its antiderivative. So here's what's funny. Obviously, if there's a prime, the antiderivative just unprimes it. It's undoing it, yes? But there is something for this. We just make it what I affectionately call big ass F.
The ln.
So the antiderivative of little f
It's
is big ass F. Now the antiderivative of big ass F is not bigger ass F. Don't worry about it. We'll get there. Then we'll develop a better symbol that you kind of alluded to, yeah? But for right now, if I'm just working with one step, obviously if there's a prime, I just take the prime away when I undo the derivative. But if it doesn't have a prime and I need to do an antiderivative, I just capitalize the letter. So if it was g of x, it would be capital G of x would be the antiderivative. Are you guys with me?
What about like second antiderivative?
That's what I said. The minute we want to do more steps, we're going to have better symbols. We'll get there. For right now, just this one step is good. We're going to use this symbol to help us prove the other relationship for a better symbol. So we don't have to have like a bigger F or something stupid, yes? Can anyone tell me what this is, though?
4 to the x 1 over natural log of 4.
Do it again.
4 to the x times 1 over natural log of 4.
Ah, yes. It would be this. So what's the derivative of 4 to the x?
4 to the x
Times natural log of 4, yes? So if I said that, I think that's the answer. This guy's derivative would have an extra natural log of 4, yes? Which is not what's here. So I have to kill it. So I divide by it. It's the exact same thing if I had like, just to go to the e to the, what if I had e to the 2x? Why can the answer not be e to the 2x? Why is that not the answer? Because what's this guy's derivative? 2e to the 2x. Is there a 2 here?
No.
So what do I put here? Now again, I want you to really get this. Students, look at this. I have written a guess. This is my guess. It is wrong. I can see now, since I wrote it for myself, I can see it's wrong. So I'm going to add something in to make it right. And students feel like I'm cheating when I do that, but I'm constructing the answer. How do I know this is wrong? Because its derivative would have a 2 here. There's not a 2 here. So what must there have been here to kill that 2?
Divide by 2.
Divided by 2.
Oh, that's
Yes. It's the same idea as this shit. Divide instead of multiply. Yes? Why does that make sense? Because aren't I doing the opposite operation? So if this derivative multiplies by 2, the antiderivative divides by 2. Now, I'm pushing my luck. One more thing, though.
I'm gonna say one more thing, like 6 things.
Two more things. I promise. I'm going to write both things down, and if I try to do anything else, just walk out. Yes? Everybody hear me? Just walk out. Okay. Does anyone know what this guy's antiderivative is? Don't overthink it.
Natural log of x minus 1 plus
Absolute value. Okay. And that works because the chain rule would only be 1. I don't have anything to account for. Does that make sense? Like I did over here, I had to account for the 2 and so forth. Yeah. Now, what mistake might some of you be making right now? Or if you're not, can you imagine the mistake somebody makes with this?
sine of negative 1. I mean,
No,
cosine
no.
of negative 1.
What mistake would somebody write down here?
we make it 1 over cosine.
No, well, yes. One mistake is this, which is not good because this is on the bottom, which means it's fundamentally a different function than sine. But the more common mistake I see is this.
That makes sense.
That is wrong. That is so desperately wrong. Very wrong. Unbelievably wrong. What's the only thing that leads to natural log? 1 over x. Or 1 over x shifted by something, yes?
There's no x.
The minute that is different function, it is not related to natural log necessarily. Not directly anyway.
So it is to be cosine minus 1.
No. So this one would take a little work.
Oh.
I mean, this is cosecant. Now that one would take some work. Do we know anything whose derivative is this? Do we have anything memorized whose derivative is cosecant?
The derivative of cotangent is negative cosecant
Negative cosecant?
squared, so that's not gonna work.
Oh,
We don't currently know this answer.
square root of cosine?
We know. Can't take care of. So what I'm trying to get you guys to understand is, you have to pay attention to what the rule was to begin with. Natural log of x derivative is 1 over x. What would the natural log of sine x derivative be?
Tangent.
Yeah, it'd be 1 over sine times the derivative of sine, which is tangent, which is not this. So therefore, that cannot be this guy's antiderivative, because his derivative is not equal to him. So as we get into these antiderivatives, there are assumptions that students make that aren't true, and I'm going to try to point them out ahead of time, so you don't do them as you do the work. But for right now, it's plenty. Go have a really good long-ass weekend. Don't come tomorrow, because the school will be closed. Have a good 4th of July, whatever you're doing.
Tomorrow. Yeah, I'm gonna do 4-7 today, and then